And the next step is going to be to form an assembly of two of these spur gears. And to do so, we'll start a new file. We have our actual gear here that we can insert. I'm going to insert two of them, so I click on the pinhead so I can do this twice. Now the first element that I put in there is going to be fixed in place, and I want to fix that because I don't want it to actually be locked in place. Right now I can't move it at all, whereas this gear I can move around and rotate and so on. So if I go to gear 1, I can actually right click on it and allow it to float. Now none of my objects are actually fixed anywhere inside this, but I do want to restrict these from motion in terms of that direction in and out of the plane and up and down and side to side, but I want to be able to rotate that. And to do that, what I'm going to do is actually turn on temporary axes, which allows me to see the center axes. And if I can restrict that axis on two planes and I can restrict this face on another, the gear will be allowed to rotate, but it won't be allowed to translate whatsoever. And so we can arbitrarily attach that face to our front plane. We can place this axis on our top plane, and we can place this axis on our right plane. Now this gear can only rotate. It can't move in and out, can't move side to side or up and down. The next step is going to be to place this gear on the same plane in this direction, and as well space it out vertically. And again, we want it to be able to rotate, so we're going to use that axis as well. So we can mate these two faces together. And we can set this axis to be on the right plane, which keeps this gear directly above the other. And we can specify the distance between these two axes. So we, instead of allowing it to be coincident, we specify the distance. Now again, these are 18 two gear sets with 2 teeth per inches, so they have a pitch diameter of 9 inches. The distance between the two is going to be the average pitch diameter. In this case, it'll be 9 as well. So if we specify that as 9, then they're exactly spaced correctly. Now notice that they're actually intersecting with each other, and that can be a problem. So we need to figure out a way to get these things lined up initially, and we can use a mate to do that. So if I select our first gear, and I pick our right plane, I can make that plane coincident with the right plane of the assembly. Now I don't want to do that permanently, because once I've done that, I can't rotate this gear anymore, and so I can actually go to that mate and I can suppress it, and I'm going to leave it in there as suppressed, so that if I ever want to snap that gear back in place, I just have to unsuppress that feature. We'll do the exact same thing for this gear, but you'll note that if I use that right face and I make it parallel to the right plane of the entire assembly, the two gears won't line up. So if I rotate this gear to where that's perfectly vertical, the teeth actually intersect. I want that to be one step over, or in this case, I can actually rotate it 90 degrees. And I can make the right plane parallel to the top plane. Now this gear can't move, that one still can. So I want to suppress that feature. I'll re-enable this one to get it relined up, suppress it. Now we've got two gears that are actually meshed exactly correctly. We can look at them from the front, zoom in, and see that it is actually lined up exactly. So we're done with our temporary axes. Let's turn those off so we don't see those individual axes everywhere. Last step is going to be actually mating these two gears such that they rotate relative to each other. And there's actually a special kind of mate for that. We can use a mechanical mate, and we can use a gear mate. And so here it's just a matter of picking two surfaces that are going to rotate relative to each other. So if I rotate this slightly, I can pick the bottom gear, and I can pick the top gear. And now you have to pick the ratio. So normally you'd want to put the actual gear values here, but we can leave 1 to 1. It's the same thing. So if this was actually a 9 to 9, that's going to give us the exact same ratio. So let's go ahead and put that in there. If we wanted them to turn exactly the same direction, we would click on the reverse, but they are going to turn opposite based on how they're meshing, so we'll leave that the way it is. That should be all you need to actually define that relationship. And so we check out of there, and now these two gears are locked in place with each other. doesn't matter which one I drag, they're going to move relative to each other. And if I want to snap them back to an initial position, I can re-enable either of these and it repositions the entire gear mesh. So the last step is going to be to show you how to actually generate an animation using a motion study. And so SolidWorks has a pretty cool feature for generating videos based on your assemblies. You can do explosions, you can simulate motors turning, and so on. And so I will get this initially lined up, and then we will go to our motion study tab on the bottom left. And so here we see our gears. Now I'm going to change the way this is viewed because I think it's nice to be able to see the profile behind. So we're going to use the hidden lines to kind of see the depth of the system. And so here we basically have a progression of time that's going on. If we want something to actually happen, we have to use some of these features. And so I'm going to select a motor. And I'm going to select which component is going to rotate based on that motor. And it's going to be rotating at a constant speed. Now 100 RPM is going to be a little bit too fast for our video. So I'm going to lower that down to 6 RPM. And so when I do that, it creates actually about 5 seconds of motion. If we were to play this, we can actually see the gears rotating. If you want to make the animation occur longer, you can drag this over. So let's make this go for, let's say, let's do 12 seconds. Now it'll continue to rotate a little bit longer. You can add other stuff in there as well too. So if you want the video, or if you want the assembly to change its view along the process, well, we can go over here. We can set the actual view using the orientation. So I'm right-clicking there, view orientation. Let's start off with the front view, and then we can actually specify the view over here. Let's say we want to view it isometric at that point. Now it's actually going to translate between the two automatically for you. So it's going to do a pan kind of around the actual gear assembly while it's rotating. So if we play our animation, you can see that it actually works correctly. So the last step is actually just to export this. So we can use the same animation feature. There's quite a bit of settings that are available here. We'll pick a file name. We're going to use a Microsoft AVI file type. You can do a series of bitmaps, but that's going to generate a lot of data. So it's going to use your actual screen size for this. So this is one of the downsides, is it's going to pick this area right here and use that for our actual animation. So if you want to condense that, you have to kind of reshape the window in SolidWorks. Of course, you can go back and edit it later, but if you have a full screen on a large monitor, you're going to generate a pretty big video file. This frame rate's probably a little bit too slow. I'd say 15 or 30 is reasonable, so let's just go ahead and choose 30 just to see what it looks like. We're going to save this now. We have several options for video compression. The Microsoft video is fine. We'll leave that compression quality the way it is and hit OK. And so now it goes through and it actually calculates the motion study more accurately than it was doing before, so that your video is smoother. It's not going to be as jittery as you see in SolidWorks. Alright, so now it's done. Our file should be there, so let's go ahead and look for it. Here's our folder. We saved it as Gear Assembly 2, so we can open up that video, and there you have it, a video in Windows that will actually play your animation.